In this grade 12 tutorial on proving identities, we are proving that the left hand side is equal to the right hand side. Now the big idea is, obviously you want to choose the side that looks a bit more complicated. So ending up with cos x over sin x, we may be thinking of a scenario like that. So whatever we do, we may not necessarily want to keep the tan, but if we do keep it, it might help us. But funny enough, that's not usually how it works. But anyways, let's just see what we can do to end up with this. The top part, we don't want to do anything yet. You don't want to just change things just for the sake of it. So the 2 tan x, right, and the minus sine 2x, obviously at the bottom, the tan, we're going to have to change it. The reason why the tan is going to have to change is because this also is going to change. And this is what I mean. The tan x, you can write it as sine x over cos x. And then the sine 2x, you can write it like that, you see. Let me put this over 1 also, you see, so that you can see what is on the same level and what is at the bottom. So with this all being done, it looks as though this bottom part here, we may have to get an LCD. And getting an LCD, it doesn't look like it's going to be a very difficult thing to do. It's actually going to be a bit straightforward. But without even doing that, we can actually take out a common factor, because you see, this is one term, this is one term. They both have 2 sine x in them. Now obviously you can see me getting an LCD, yeah, that was gonna do something, but it looks like it was just gonna complicate the question first before it actually gets simple. So here let's just take out 2 sine x at the bottom. You see here there's a 2 sine x, we can take it out. There's a 2 sine x, we can also take it out. At the top we can actually also take out a 2 sine x. Dang it. Okay, so let's do that. If you take out a 2 sine x here, sine x is going to be left. Now at the bottom you have to be careful now, because here if you take out a 2 sine x, what you're going to have here is just 1 over cos x, and then here what you're going to have is just cos x over 1. And then yes, you can definitely then just cancel that and that also. So what that leaves you with is sine x over 1 over cos minus cos over 1. So obviously this looks like it's going to be easier to deal with. So what you can actually do for yourself is, you want to get used to stuff like this in math. This denominator portion of our big expression, we can actually just work on this for a bit and then see how far we can go with this in terms of making it look simple, and then carry on with the main question. So what I mean is the 1 over cos x and minus cos x over 1. Let's write it here. You see, let's just simplify this into at least one single fraction. So to do that, we said our LCD is just cos x. So this fraction we can multiply it by cos x over cos x. And then what's going to happen, this is going to give us cos squared x, and then everything is going to be over cos x. So since now we know that this thing here is equal to that, we can now carry on with our main question. And this is something you can definitely always do, so that you don't find yourself like, you know, writing out too many things unnecessarily. So this can be like on your answer sheet, like on the far left or on the far right, wherever. And then carrying on from here, this is what you can have. Now the good news is, with what you have here, right, you want to keep in mind that this is your main fraction, the top part divided by the bottom part. So what you can actually do, you can write the sine x over 1 divided by your fraction. And then what we know is, remember, if you're dividing a fraction, you can just flip it over and then change your division symbol to a multiplication symbol. There we go. So the top times the top, the bottom times the bottom. Now the bottom part here, if you can see there, that's just part of our square identity, because remember, is equal to 1 minus cos squared x, you see. So where we see here 1 minus cos squared x, we know that's just equal to sine x squared, you see. So with that being said, one sine can cancel one sine, and then there we go. The left hand side is definitely equal to the right hand side over there. So yeah, with trigonometry proving identities, you definitely want to do more examples. If you want to go through more examples, this playlist is going to take you to those examples.